Hey guys, I'm going to go over the review for chapter 5, and I'm also going to show the Alex part as well. So just so you guys know, that for these first 3 questions right here, I don't think I'm going to have any questions like this on the test, so I wouldn't worry about answering these right here. But let's start with question 4. So simplify the expression and use positive exponents only. So here we can add the exponents because they have the same base and we're multiplying. So negative 2 plus 7, that's going to be negative 2. But that does leave us with a negative exponent. So we're going to rewrite this as 1 over e squared. And so if you guys are looking in Alex at the review, we have the same question. So we're going to write this as we can use a fraction and then 1. And then we can go ahead here and do an exponent. So we can press the exponent button. And that's the bottom right of one row up from the bottom, or the one row up. So the third row to the far right is the exponent button. And then we're going to do E. And then if I can click in there, we're going to do 2 right there. And that's how you can type that in. Okay, for the next one here, so this right here, I can evaluate the cube root of 8, which would be 2, and then I can change the exponent here to be 12x divided by 3, which would then be 2e to the 4x. And so that's what I would type in here. So I would type in, you can do 2, and then we can type in e right now. And then if we want, we can press the exponent button, and then that'd be 4x. So 2e to the 4x, is that what we said? Yeah, 2e to the 4x. For this one right here, this is very similar to the one that we did over here. We're just going to add exponents, and so we can do the same concept here. So this would be e, and then we have 2x plus 5 plus x minus 2, and then we can combine like terms, so 3x and then plus 3, so e to the 3x plus 3. So here we can do an exponent, so e, and then we can do 3x plus 3. Okay, for these ones right here, now you're not going to see these exact ones in Alex. You're going to see different ones in Alex for number 4, but I think it's good to just practice all of these right here. So let me go through and practice these. So rewriting these in exponential form, so this would be 2 to the negative 5 is equal to 1 over 32. Okay, and then this would be 4 squared is equal to 16. This will be 1 over 10 to the 0 power is equal to 1. Okay, now for these ones, writing these in logarithmic form, so this will be a log base 2 of 8 is equal to 3. Here we'll have a log base 1.25 of 1.5625, and that's going to be equal to 2. And then here we'll have a log base 2/3 of 9/4 is going to be equal to negative 2. And then you can try the ones that you have here. So if you have different ones, that's good. And then every attempt that you make on this review in Alex, 4 should populate different ones each time. Unlike the 1, 2, and 3, that's going to populate the same ones. But here, so for A, I would write this as 3 to the 4th power is going to be equal to 81. And then for B, this would be a log base 8 of 1/8 is going to be equal to negative 1. Okay, 13, I'm probably not going to have a question like this on the exam, but it should be B. So which of the following expressions is equal to x? So because this is a common logarithm, its base is 10, meaning that these will cancel each other out, leaving us with just x. Okay, and it'll use that same property, I think, down here. Now for these ones, again, so for these ones right here, these aren't going to be the same things than what you see in question 5 right here. So question 5 is going to populate different ones, and that's good to practice. So let me just go through all of these, and then I'll do the ones that are in ALEKS. So this logarithm will produce some value, so I can think about it as an exponential. So 2 to what value will give me 16. And so if I think about what power exponent this is, that will also tell me what the value of this logarithm is. They'll be the same. And so this would have to be equal to 4, because 2 to the 4th is equal to 16. And then here we can think about this as 5 to what power is going to be equal to 125. That's going to be 3. 5 times 5 is 25. Times that by 5 and you get 125. Here, so 6 to what power is going to give me 6? That's going to be 1. And then 32 to what power is going to give me 2? So in this case right here, because we're getting smaller, so the value is getting smaller, that means that this has to be less than 1. And you can think about it like a fraction, I guess. But if I also think about it in the reverse order, 2 to the 5th power is 32. So 32 to the 1/5 power will be 2. So this is going to be 1/5. And then here, 4 to what power is equal to 1/4. Now in this case, this is becoming a fraction, which means that this has to be negative for that to happen. And 4 to the 1st power is 4, so then 4 to the -1 power is 1/4. So this will have to be equal to -1. A natural log or a log with 1 is going to be equal to 0. Don't really need much for that. And then here, 10 to what power is going to be equal to 100,000? That's going to have to be 5. 1, 2, 3, 4, 5. Yep. So that's going to have to be equal to 5. 27 to what power is going to be equal to 3? Same thing up here. Notice that I'm getting smaller. This has to be less than 1. And 3 to the 3rd is 27, so that has to be 1/3. The reciprocal of that, 1/3. And let's try the ones that we have in ALEKS. So again, if you keep retrying this quiz right here, you'll get different values, or you get different questions here. So 8 to what power is 1/64? So I'm getting a fraction, so this has to be negative, and that's going to have to be -2, because 8 squared is 64. So 8 to the -2 will be 1/64. And then 3 to what power is 27? That's going to have to be 3. 3 to the 3rd is 27. Okay, and then for this one, so this one will match up with what you get, with what you see here. And so simplify this expression. So I have an exponential with a log of base 5. Since those are inverse operations, they will cancel, leaving me with just x. So solution here is just going to be x. And for 7, so for this one right here, I want that to be the same base. So if I rewrite this, I can rewrite 16 as 4 squared. And then this is a power to a power, which means I can multiply those. And so that's going to become 6x. So log base 4 of 4, those are going to cancel, and I'm just going to be left with 6x. So here, this should be just 6x. And then for the next one, so we have an exponential with a logarithm of base 8, so that's just going to leave me with 5x. So right here, that's just going to be 5x. And then for this next one right here, This one is just going to give me x, since natural log is a base e logarithm, so those will cancel, leaving me with just x. Okay. The next couple ones are just doing inverse functions. So to find the inverse of this function, I'm going to switch x and y. Okay, and then I need to get y by itself, but it's inside the power of this exponential. So I'm going to do a log base 4 on both sides, and that's going to cancel out here, leaving me with y, and then this will just be a log base 4 of x. So this would be my answer. Now, whenever you're typing this into ALEKS, it won't allow you to do an equal sign, so just write in the equation or the formula part. So let's do a log, we'll do a log base 4 of x. And that's all you have to type. Don't type in y equals. I don't think it will let you. Okay, and then for this one right here, so x is equal to e to the 5y. So I can't divide by 5 yet, but I can use a natural log, because that's going to cancel. So I'll get the natural log of x is equal to 5y, and divide by 5, divide by 5. So I'll get y is equal to the natural log of x divided by 5. So then in here, make sure you use the fraction button, so that's the top right button. And then we can press the natural log button, which is the bottom left. So natural log of x, and then in the denominator, we'll put in 5. Okay, and then here, so we'll switch x and y. Let's subtract 2. So we'll get x minus 2 is equal to 6 to the y. And then I need to get rid of the base 6. So I can only do that by doing a log of base 6 to both sides. So then that's going to cancel here. So I'll get log base 6 of x minus 2 is equal to y. And the parentheses are very important here. So I'm using a log base 6 of all of that right there. I'm going to want parentheses. So log base 6, so here, press the log button, log base 6, and then we're going to want to use parentheses of x, plus 2 or minus 2? Minus 2 of x minus 2 close parenthesis. Okay, and then moving on. Okay, so down here, so x is equal to log base 2 of y plus 2. Notice that there are no parentheses here, so I can start by subtracting 2. So I'll get x minus 2 is equal to log base 2 of y. And then here, we're going to do what's called exponentiating, because now I have this logarithm. So I'm going to give this a base of 2. So 2 to the x minus 2 is equal to y. So those are going to cancel, leaving me with y. So I just have 2 to the x minus 2. So 2 raised to the x minus 2. Now, I don't have this one. I've taken this one off the review because I don't want you guys to do a problem like this in ALEKS, but it might be good practice to do here. So x is equal to a log base 1/3 of y minus 1. So this is a log with a base of 10. So we would do 10 base. So 10 to the x is equal to 1/3y minus 1. Then we would add 1. So that would be 10 to the x plus 1 equals 1/3y. And then we would multiply by 3. So that would be y is equal to 3 times by 10 to the x plus 1. And again, for formatting, there's just too many different ways you could write this, and formatting the answer will just I don't want to have to do that, so I took this out of the quiz. Okay, and then here, so we have x is equal to the natural log of 3y. So we're going to exponentiate both of these sides with a base of e, because that will get rid of the natural log here. So e to the x is going to be equal to 3y, and then I can divide by 3. So I get y is equal to e to the x divided by 3. So this will be e to the x, and then here divided by 3, e to the x divided by 3. Okay, and that should do everything. That should finish everything for the part that's in ALEKS. Okay, now as far as the graphing part goes, so on the graphing part you have 4 log questions and you have 4 exponentials. On the test, oh wait a minute, before we get to those ones, we actually have these questions right here. So write a rule, so let's go through some of these. Okay, so write a rule that represents the indicated transformations. So left 2 units, so that's going to be x plus 2, and then this will be plus 3, and a vertical stretch by 2 will be 2 times by f of x. So let's go through these step by step. So g of x is going to be equal to e to the negative x plus 2. So x plus 2 should look like that. And then plus 3 right here. And then we should write it as 2 times by the function. So that's 2 e to the, I'm going to write that as negative x minus 2 plus 3. So I was just simplifying that part. And this should be fine, but then you can also distribute that to be 2 e to the negative x minus 2 plus 6. Here, so translation 3 to the right, so that's going to be minus 3. And then, so this will be x minus 3 minus 1, and the reflection across the x-axis will be negative f of x. So g of x is going to be equal to a log base 9 of x minus 3 minus 1, and then for the reflection, that's negative log base 9 of x minus 3 minus 1, which the negative can be distributed to those two terms. So negative log base 9 of x minus 3 plus 1. Okay, for this next one, so vertical shrink by 1/4, so that's 1/4 times by the function, and then plus 5. So g of x will be equal to 1/4 e to the x. Now, because this plus 5 is coming after, I don't have to distribute the 1/4. I can just do plus 5. So because I'm multiplying this by 1/4, so I'm multiplying this before I'm adding the 5. So if these had been reversed, we would add 5, and then I'd have to multiply by 1/4, which would mean that that would have to distribute. But that's fine right there. And then for this one right here, so stretch by a factor of 9, translation 2 units to the right, that's going to be x minus 2, right? And then minus 3. So g of x is going to be equal to 9 log base 1/6 of x minus 2, and then minus 3. So I don't have to distribute the 9 because the multiplying comes before I do any of that right there. So I don't have to multiply that by 9. And then don't need to do 40. Okay, and then let's go on to the graphing. So I'm going to start with the exponentials. So this one is an exponential decay graph because this is less than 1, and with a base of 3, that means it's tripling. So I always start my initial point right here as 1, and then that needs to triple, so 3, and then the next one would be 9. So this creates a decay model like that right there, and then we're just going to add 4 to all these points. So 1, 2, 3, 4, 1, 2, 3, 4, and then the asymptote, which would have been here, is also going to be moved up 4. So the asymptote can be put right there. And so this is what the graph should look like. The domain is all real numbers for exponentials, and the range depends on the asymptote. And the asymptote is y is equal to 4. And so since we're above that line, y is going to be greater than 4. Okay, now for this one, we have a base of 3 rather than 1/3, which means we're going to have exponential decay. So again, I'm going to plot my point here at 0, 1, and then we're going to triple that. So that's going to be 3 and then 9. And then these points right here are going to be moved to the right 2 and up 1. So right 2 and up 1. Right 2 and up 1. And I think that's about all I can graph. And the asymptote is also going to be moved up 1. And so that would put that right here. So this is y is equal to 1. And then we can draw our points accordingly. Domain is going to be all real numbers, and range is y is greater than 1. Alright, this one, I look at that part first. So this is going to be quadrupling. So here, and it's growth, so then those are the first 2 points. The next point would be up at 16, since 4 times 4 is 16. And then these points I'm going to reflect and move up 3. So if I reflect this, and then move it up 3, 1, 2, 3, it's going to put me right there. And then this point we're going to reflect and move it up 3, 1, 2, 3. So right here. And the asymptote is going to be moved up 3 as well. So it's going to be at y equals 3. And then this one's just going to be headed down. So that's what it should look like. Domain is all real numbers. The range is y is going to be less than 3. Alright, so I have a decay model and the base is 2. So starting my points here and it's decay, it's going to be doubling at a rate of 2. So then 2, then 4, then 8. And then these points right here are going to be moved to the right 1 and up 2. So right 1 and up 2, right 1 and up 2, right 1 and up 2. And then the asymptote is going to be moved up 2. So that's going to be at y equals 2. And then we can draw our points through there. Domain is all the numbers. Range is y has to be greater than 2. Okay, so kind of some things to take away is where do you start? Whether or not it's decay or growth. And looking at the base, if it's going to be doubling, quadrupling, or tripling, 1, 3, 9. So those are some things that I use to help me graph exponentials. Now, if I understand that, logs should be a little bit easier to understand, although they're still kind of confusing. So this is a log base 2. So kind of following the same concept is that it's going to be doubling, but now we're going to double it in accordance with the x-axis. So I'm going to plot my first point at 0, 1 rather than at 1, 0, and then rather than doing double this way, we're going to double growing in this way. So think about like you're doubling in the x rather than in the y. And so 1, 2, and then at 4, and then at 8 accordingly. So this would be the points for the log of base 2. And then we have to stretch by 2 and move to the right 3. So this point can't stretch by 2 because it's on the x-axis. So we're just going to move that point to the right 3. This point will stretch by 2. and then it'll move to the right 3, so 1, 2, and 3, so right there. And this point will stretch by 2, and then move to the right 3. Okay, so it should look like that. Now the asymptotes for logarithms are going to run vertically, and we have to move it to the right 3, so that would put the asymptote at x equals 3. And then the domain is x is going to be greater than 3, and the range here will be all real numbers. Okay, for this one we have a base of 1/4, so again, just think in accordance with the x-axis rather than the y. Plot my first point here, and it's going to quadruple, so that's going to be at 4, but also this is 1/4, so it's actually going to be decaying rather than growing. And so if it's 1/4, so then I'd put it here as my next point, and the next one would be at 16, but we can't graph that. And then as far as the transformations go, it's going to be to the right 2. So right 2, and the asymptote will also be moved to the right 2. So it's going to be x equals 2. And then should just look like that. So the domain is x is greater than 2. The range is all real numbers. Now for this one in class, I don't really want to draw it with a vertical shrink because they're just hard to graph, and so I don't think I'm going to test on vertical shrinks for these ones. They're just hard to graph because you're shrinking it by half, which, I don't know, it's just kind of annoying. So I'm just going to forget about that just for the sake of making it easier. So, but it is a base of 1/2, so it's got to be decay for a logarithm. So I'm going to start my first point here, and then we're going to double. So double it, and double that. Okay, and all of these points are just going to be moved up 2. So 1, 2, 1, 2, 1, 2, 1, 2, and the vertical asymptote is not changing. And so that means that the domain is x is greater than 0, and the range is all real numbers. And last but not least, we have a base of 3, so put my initial point here, and then we're going to triple it. So 3, and then it'd be at 9. And then this means that we're going to move to the right 3. So 1, 2, 3, 1, 2, 3, and the asymptote will be moved to the left 3. So like that. So domain x is greater than 3, and the range is all real numbers. Okay, and that should be everything for the graphing, and I think I've covered everything that's going to be on the test. Keep in mind that the graphing and these type of problems are going to be on paper, but everything that I did up here and what you saw in ALEKS will be on the ALEKS portion, which I will allow you to do one retake for full points, and you only have to retake the questions that you missed, and it will be done in ALEKS. So hopefully this is a good enough review, and let me know if you have any questions.